All right, good evening. About a week ago, I released this video in a raw format because I felt it was evidence enough as it is, but I thought I do want to go in there and quickly assess some of the details inside this video, and that way I can at least speak about the angles and stuff like that I found. But of course, the most amazing thing about this was the wind turbines. I will quite happily like other people to test, my thoughts on this, test my details, and I also put together an Excel spreadsheet when I was having a conversation with Roohif, and he gave me a couple of videos which basically stipulated how he, uses milliradians inside the dumpy level to be able to identify how I pitch down, because obviously, as you can see the crosshair in the center, there's a marker at the top and a marker down the bottom line. There's like a positive and negative stadia lines, and he says I think there was 100 milliradians from one to the other, or maybe it's 10. I think it might be 10 milliradians from the top one to the bottom one. So it's like -5 to the bottom and +5 to the top. So I went and created this to sort of help me understand some of the formulas he was doing, because he had a whole bunch of stuff like, he had all the math stuff which I haven't done. I haven't touched this sort of stuff since high school. So when I look at that, I want to break it down into piece by piece segments so that I can go out there and break it down. So I went and wrote down everything that it was. I had put an inputting area here, and I just let them crunch the numbers bit by bit. And of course, this whole formula down here, this was for something that he did in one of his videos, which can help someone go out there and reverse engineer where their observer height is. But I wasn't worried about that one for this one, because I already knew what my height was, because I knew what my contours were. The only thing I wanted to go out there and do was punch in my milliradians. So inside this, see what I did here, right, is I took my best possible screenshot, which had both the turbines in the background and something where I could slightly see the stadias, because there was a lot of, because it was blending in with the sun, there is a lot of moments where you can't see the stadia at all because it just goes blank. And so I waited till there was a little bit of shadow onto the left, which caused the stadia lines to just pop out. And so I took the screenshot where I could best see a stadia line, and I mimicked that with my crosshairs and with my sun setting behind the wind turbines. Right, so details first. I was at Matthew Flinder's Matthew Flinder's cairn, which we call it cairn, which is like a stack of rocks. And that was on August the 2nd. This is the coordinates, and this is the observer height. So about 258 meters high. And according to Roohifs' Stadia calculator, with about a -6.95 stadia down. So this was this distance down here. Once I scale it, I got -6.95 stadia down. And so I estimated the angle down to be 0.3982 degrees down. And you'll see here, over here in this thing. So I put in the 6.95 milliradian, and the arc minutes is 23.89, but the angle, which I kind of like better anyway, was 0.398. So, you can see here, if I actually change the number, everything auto updates. So really handy, and I'm hoping to upload this to the cloud and just let anyone who wants to download it and use it themselves. That's if anyone actually has dumpy labs, of course. So I went on the sunset time, so August 2nd. Sunset says 292 degrees west-northwest. And so according to that, I just took a broad screenshot and I just drew an angle of 292 degrees, and it was roughly pointing straight through Geelong. So I couldn't believe that. It was actually going straight through the city of Geelong. It was going up near this Wyneth and Rockwood and Barana Park and all that sort of stuff. And I was like, not 100% sure of that. So what I will find out is I went and found out where the wind turbines were. There's a couple of wind turbines around, but this one seems to be near Rokewood, right? And so Rokewood is right up here. So it's in this region. Now, if you see the way that this yellow patch works there, I've got to flick it over to here. So as you can see here, this is that wiggly yellow patch right here, and so it's in this nook right where this pointy bit is. And as you can see, so this turbine's apparently in this quadrant right here. So this angle's pretty close. So I'm satisfied that the wind turbines I was looking at is the Rokewood ones, right? Or Golden Plains. And so as you can see here, Golden Plains, Rokewood. So there seems to be some wind turbines in this pocket. Now I managed to I did a quick distance. So from the viewing mountain that I saw, went straight over top of Geelong, and over to that same Rokewood wind turbines. I'm estimating it to be 113.8 kilometres or 70.7 miles. Now I went out there and went to the survey mark inquiry service, and I found out a survey mark that's right in the middle of the wind turbine zone. And we've got PM13, which is 173 metres above Australian height datum, which is basically 173 metres above sea level. So I thought, okay, I'm going to get all those data points. And so I quickly drew this in, just like I drew, this one in over here when I did this the other day. I drew the same thing over here. So I did a mountain. I did observer height of 258 metres. And so the green line is the view line, and the yellow line is the flat earth line, and the orange is the mountain. And as you can see, I got a little man up here, so that's me basically looking through the viewport, right? So that's Matthew Flinders' can at the top of that mountain, right? So when I the distance 113.8 kilometers, right? So I did this ring. I did this ring of 113.8 kilometers, right? So that's roughly where I would expect the intersections to happen. So as you can already see, this yellow line is the flat earth line. That's level with the bottom of that mountain. So the yellow line starts from the very bottom, right below the mountain. Okay, so the yellow line is here, and as you can see, the green view line is already looking below it. And I mean, I can understand. I haven't included refraction because, to be honest, I'm not like Roohif. I don't know how to compute the refraction levels depending on temperatures and all that sort of jargon. I don't really know how to do that sort of stuff. So this is straight line geometry. So as you can see, the green line of negative 0.39 looks below what a flat Earth would be. So this is already, I believe, is already knocking the flat Earth down, because the flat Earth, realistically, if it's at level 0, you should be able to see forever and ever and ever and ever and ever and ever, and ever. And it should be, and you should never see a negative height. I mean, if anything, I would probably accept, a 0.000002 degrees down or something like that, but never what's almost like half a degree down, like 0.39. That's pretty much 0.4, so it's like half a degree down. Now this grey circle is a 200,000 kilometer Earth. The blue one is the typical Earth, so that's 12,756, and the white is a 10,000 kilometer Earth. So when you zoom right out, what you will see is this is a 10,000 kilometer Earth. This is a 12,700 kilometer Earth, and this is a 20,000 kilometer. Sorry, there's a bit of a typo. I'll get rid of that. That's a 0. 20,000 kilometer, right? And this yellow line is flat Earth. So I mean, yeah. As you can see out here, I mean, this view line realistically is looking what seems to be 67 kilometers below flat Earth. So that view line, if it kept on going out to the same width as what this large Earth would be, 67 kilometers below the horizon. So that can't be right. Now, the AHD height was 175 meters. Now, I don't know whether or not the land is lifted, it's loomed up to be able to meet the the view line, or if it's dropped. I would imagine that because it's sunset, sometimes they loom, and which means that they probably would rise. Now, to be honest with myself, the blue line is currently below it right now. But what I will do is I will create a ring which is 175 meters high. Right, so this blue line here, right, that's sea level. So if I was to put a ring here of 175, so that's supposed to be ground level right there. That is supposed to be ground level. So it's certainly a lot closer to the green line than what the flat Earth, negative angle is. Because, I mean, we're looking below flat Earth here, but it's certainly not going quite down to here. So, I don't know, to be honest. From the Earth's true radius, the view line is still looking over, but like I said, I don't know anything. I can't tell you about refraction, but I'm showing you the results of what I think it is, and so the missing sort of the amount of difference that the refraction would have to be would be 325 meters of drop. So whatever land mass, unless of course there's a land mass in front, I just don't know. There's potential. Like, what I don't know is I don't know whether or not there's any land masses closer up, right? Which could be interfering with it. Because as you can see here, you can see that this land mass is like halfway up these wind turbines. These wind turbines are literally getting half blocked. So I don't know if there's a land mass in front of it. Like, if there's a possibility that I was to do. If I was to be able to see further down to the very bottom, I would imagine that my angle would be greater. But I just don't know. Let me just have a quick look and see if there's any other land masses. I don't really know. Maybe this thing could be higher. I just don't know. How about, let me check the survey marks. So let's see if there's any other survey marks in the region. Let's go for this one here. 175 again. So that was that one there. So that one, 168, 175. That's 147, 146. Some of these heights are lower. The only thing is they are closer, which means that on a globe, because those objects are closer, that's 39 meters. That's even lower. What's this? Oh, here we go. Look at this. There is literally a small mountain range at the back of Geelong here. Let me just double check my map here. Oh, right over, just over to the north. It seems to be going through this car parking. Sorry, this portion right here. Let's have a look and see if there's anything near Stoneham. Oh, that's 39. That's not tall enough. I don't know. I'm not seeing much. Not seeing much at all. That's 77 meters. Either way, I think it still stands that if anything of a similar height is closer, it will be raised up higher in front. So, like if it's something 50 kilometers closer, and it's a somewhat matching height, it might block out my view. which might cause me to not quite see the bottoms of these wind turbines. But yeah, look, I'm not going to beat a dead horse over this sort of thing. I just wanted to find out what it is, and it's possible that if there is an object over here, let's say for instance over here, let's say that's 175 meters too. So if I go back to the viewing angle there, roughly along there, see, yeah, and some sort of object that is closer will raise the that flat spot up higher. So look, it could be a combination of the refraction making it lift and loom because it is behind a sunset, and potentially some sort of landmass in front, which this image would tell me that there is something in front. I mean, my levels are to the ground. They aren't taking into advantage of any 50-meter tall trees at all. There could be a forest in front of this entire area, and I will just never know until I actually drive out there and have a look. But I don't plan to drive out and have a look at anything. I mean, like, there's literally some trees right here. So what the hell are these trees? They're kind of like 50 meters tall anyway. So that's the thing. Any one of these trees on this path could be raising it up and then changing my perspective. So yeah, like I said, I'm not going to beat a dead horse about it, but the truth is that, you know, an angle down on a flat Earth just shouldn't happen. It just shouldn't happen. And this is pretty close to the globe prediction. It's not perfectly close, but it's understandable. So I'd like to upload the Roohif angle calculator, and so you may see that in the comments. All right, so that's my celestial theodolite experiment, because those boys have been going on that thing for 6 months, trying to look up at like something that's 2.2 degrees upwards. Whereas my observation here is looking 0.4 of a degree downwards. All right, I mean, that's challenge. I get any flat earther to go out there and find me some sort of occultation of a sun. This is a star, just like they are saying that their star is being occulted. The sun is a star, and it is being occulted by land masses over in the Geelong region at -5 degrees below eye level. So put that in your celestial theodolite and fucking eat it. Good night.